Hi, today we are going to do Newton's third law lab. This particular lab focuses on how forces in action-reaction pairs work. What you're going to want to do is open up your lab notebook and create an entry with the proper header in the next space of your lab notebook. Make sure that it is also located in the table of contents. It's referenced there in the table of contents. Once you've done that, you will then create a purpose statement, and the purpose statement can be seen on the bottom of your screen. It says the purpose of this experiment is to determine the relationship between the forces forming an action-reaction pair, period. Do not include anything that comes after that. That is your purpose statement. What we're going to do is we're going to use force sensors, similar to what we've used in our Newton's second law lab, and we are going to attach them together, and we are going to pull them apart and compare how the force on one force sensor compares to the force on another force sensor. So in the write-up here, in the document, the capstone document, I've already set up here a graph. This particular graph has a blue and a magenta line on it. So we can see that when I pull out on the force sensor, I get a magenta, or a blue line that represents the amount of force. If I push in and it goes in the opposite direction. So this is going to stay always in this hand. So you will always see the blue on this particular hand in your video. And on the other hand, you will see the magenta. So I pull on the magenta, it goes the opposite way. So when these two things are connected and pulling, one will be pulling to the left, one will be pulling to the right. Let's give this a try. So I have here the string. The string will connect together the two force sensors. I am going to make sure that the force sensors themselves are taired. So I'm going to start my graph. I'm going to make sure everything is taired up. And again, I'm attaching the string. And I begin to pull. And as I pull with my right hand, the graphs match. As I pull with my left hand, the graphs match. As I move the object along, pulling in one direction or the other, the graphs match. This is Newton's third law about action-reaction pairs. If the right hand gives an impulse or the left hand gives an impulse, we get the equal and opposite impulse on the other side. Newton's third law says for every action, there is an equal and opposite reaction. I cannot pull on the right side without also applying an equal and opposite force to the left side. So again, when I pull in one direction, the other direction has to have an equal and opposite force. If it doesn't have an equal and opposite force, the objects are moving along. But even at that point, as they're moving along, any excess force is countering the equal and opposite. And so you could see here on my graphs, as I pull on one side, I get an equal and opposite force on the other side. Now, what I would like you to do is I'm going to give you this graph. You can put this into your lab notebook to show the tug of war forces. And then I would like you to answer the questions located here on your screen in your lab notebook underneath that graph picture. So go into your lab notebook and start answering these questions about how equal and opposite reactions in Newton's third law works. If you have any questions, as always, let me know. You will submit all of this as a single-page document in the Google Classroom. If you have any questions, again, please let me know. Have a great day.